Section 1.2 is all about sets, and in order to do probability theory, we need to have a good understanding of what sets are. So sets, or a set, is a collection of objects. And what these objects will be are numbers or other sets. So our sets will either contain numbers, sets, or both. Okay, let's look at an example. So to denote a set, we usually use a capital letter. Let's say I have a set, call it A. To open the set, we open a curly brace like this. And let's say A contains the numbers 1, 3, and 5. So just by looking at set A, we see it only contains numbers and it has 3 objects. And if I wanted to list out all the objects in A, how would I do it? Well, we could say that 1 is in A, 3 is in A, and 5 is in A. But also, in set theory, we have a special symbol for the word in, and that symbol looks like this. So using that notation, we could say that 1 is in set A, 3 is in set A, and 5 is in set A. So we have 3 objects in A. Now some textbooks call the objects in a set the elements of the set. So 1 is an element of set A, and so is 3 and so is 5. Now we can also denote any other number that is not in A. So for example, the number 7 is clearly not an element of A. And in order to denote that, we basically use the same symbol, but this time we cross it out. And then we write out the set that it does not belong to. So 7 is not an element of A. So these are true statements, and so is this. So this was an example of a set just containing numbers. How would a set look like if it contained sets? Let's look at that. So let's say I have another set, call it set B, that contained 2 sets. It contained this set, which is a set that contains the elements 1, 3, and 5. And let's say there was another set in set B that was the set containing 2, 4, and 6. So set B is a set that contains 2 objects, and those objects are sets. So here's our first object. This object is a set that contains 3 objects. And this is the second object in set B that also contains 3 objects. So if we wanted to enumerate all the objects in B like we did for A, we can do so. So the first element in B is this set. So this set is an element of set B, and the set containing 2, 4, and 6 is also an element of B. Hence, there are 2 objects in set B. Now, it may look a little weird seeing sets within sets, but if you notice, this set is just set A. And let's say we gave this set a name. Let's call it set C. Then we can rewrite set B like this. So this first set is A, and this second set is set C. So now it might be a little easier to see that set B just contains 2 objects, set A and set C. We can also have a set that contains both numbers and sets. So as an example, let's call this set D. So this set will contain some numbers, let's say 0, square root of 2, pi, and then it will contain a set containing just one element, the number 1. It can contain, let's say, 2 more numbers, and it contains another set containing these numbers. Okay, so set D is a little more complex than set A and set B. In fact, it's a hybrid because it contains not just numbers, but also sets. So how many objects are in set D? Well, these are 3 objects, right? 0, square root of 2, and pi, that's 3. Then this set is the 4th object, 5th object, 6th object, and finally the 7th object is this set. So all of these objects are elements of set D. And set D is a set that contains numbers and other sets. And just to get a little more complex, just to make sure you understand that this is allowed, we can have a set, let's call it set E, that's a set that contains a set which can contain another set. So let's say in this inner set, we had the numbers 2 and 0, and then we have to close this set that contains this inner set. But then we have to close set E. So how many objects are in set E? Is it 2, 1, 0, 3? Well, if we count this as a set, then it must be one object in set E. And in fact, there's one object in set E, which is this set, which is an element of set E. And this might be easier to see again if we rename a few things here. So let's say I rename this inner set K, and then I rename this set as G. Okay, so we see a few things here that set K is an element of set G, and we can rewrite set G as this, right? So set G is right here. Furthermore, we could rewrite set E as a set containing the element G. And now it's obvious that there's only one object in set E, which is G. And these are the same thing.